Hey guys, I'm going to solve a coding problem from LeetCode today called Find Peak Elements. This problem can be solved using linear scan approach, which will have a time complexity of O of n, or binary search approach, which will have a time complexity of O of log n. I'll be solving this question using recursive binary method today. So this question says a peak element is an element that is greater than its neighbor. So an array may contain multiple peaks. In that case, return the index to any of its peak. So given as an example, array 1, 2, 3, 1. Here the peak is number 3. Here the peak is number 3. So our function should return index 2. And in the second example, we have two peaks, number 2 and number 6. So our function can return index for any of these two, which is either index 1 or index 5. Yeah, so let's start to solve this. I'm creating a new method for our recursive binary search. We pass nums, low, and high to this. So low, high, and mid are typical to any binary search. Since this is a recursive method, my mid would be low plus high minus low divided by 2. Let's cover the corner case, which means if the length of the input array is 0 or 1. So for 0, the low will be equal to high. In that case, we'll return the index of low or high, which is same. Now, if the length of this array is 2, which means we have only two values, so there cannot be a peak given in the example where we need at least 3. So I'll cover that case. So in that case, the length, the high minus low will be 1. So now we'll return the maximum of those two. So we'll do the binary search only when we have more than 3. Once we calculate the mid, we are going to compare the value of the mid to both its neighbor, which is the left neighbor and right neighbor. So this is the ideal case that we are looking for, that the mid is greater than its left neighbor and is also greater than its right neighbor. In that case, we'll return the index of the mid. So let us look at one of these examples that we have here. So let's say in a case when the left neighbor, if you look here, in a case when the left neighbor of the mid is higher than the right neighbor, that means those three elements that we're looking at is in a downward slope. That means the element on the left side has a higher value, and that's why the peak will be on the left side. So, and the otherwise. So if we are looking at a number, if we are looking at mid whose right is greater than the mid, that means it is in a increasing slope. That means the peak will be on the right subarray. So we'll just do that. If the left neighbor is greater than the value in the mid, call the recursive function for the left subarray, which is and if the right neighbor is greater than mid, and we will check these conditions only if we have already not found a peak past the right subarray in this case. And this is do not have an exception. Okay, let's try to run this code now. Compile error, it says nums dot cannot find symbol. Nums, strange, line 4. Let's try to run it again. Okay, let's submit this. Okay, so this was accepted. Yeah, 59 non-59 test cases passed. So what we did here was we looked at any array, and then we compared elements to the right neighbor and the left neighbor. In case the right neighbor was greater than the mid, we passed on the right subarray. In case the left neighbor was greater than mid, we passed on the left subarray. This is a very easy explanation using recursive binary search method. I hope you find my solution helpful, and if you want further explanation, please comment below. Thank you for watching my video. Please comment below what other kind of videos would you like me to try.